the extension that is produced in a material is proportional to the force that is applied to it, provided that the elastic limit of that material is not exceeded. So this question, we're going to be solving a question on that basis, and we're going to be looking at the work done in stretching a material. We must understand that the work done in stretching a material is proportional to the elastic energy present in that material. Alright, so we have a question that we're going to be providing a solution for. So like we always know, for every physics question, to make it easy and understandable, it's very important that you read and bring out all parameters, also indicating the parameter that you are to look for, so that you can easily relate your parameters with your topic and with the necessary formula that will help us obtain the unknown. So we start. It says that a spring of length 2.0 meters. Okay, so this is the first parameter listed here. A spring of length 2 meters. That is like the natural length of the spring. Okay, so this is the natural length of the spring, and this is given to us as 2.0 meters. It says it requires a force of 6 Newton to stretch it. Okay, so this is the distorting force that was applied to it initially, and it gave us 6 Newton. Okay, so it stretches it by 0.2 centimeters. This particular spring that has a natural length of 2 meters was stretched by 0.2 centimeters. For a material to be stretched by these amounts, that stretching is the extension produced in the material, and is given to us as 0.2 centimeters. And like we know, all parameters must be given to this to the SI unit. All quantities must be expressed to the SI unit. So 0.2 centimeters is given as 0.002 meters. So we proceed. For the second state, we're told that what work is done in stretching it by 2 centimeters. Alright? So if this is the initial extension produced in the material, we're not talking about what work was done to extend it to 2 centimeters. Like 2 centimeters will give us 0.02 meters. Alright, so we want to know the work that was done on this material to have been stretched by 0.02 meters. But one important information that was not stated in this question is the force constant of the spring. Every spring has a force constant. Alright, so the force constant wasn't mentioned here, and it's very important for us to obtain the work done. Now we need to know that the work done in stretching an elastic material, or in stretching an elastic spring, is given as 1/2kx², where k stands for the force constant and x stands for the what? Extension. So we see that the k value wasn't given, so it is necessary that before we solve anything, we must obtain the k value. Now, how do we get the k value? Stating from Hooke's law, the force applied on the material is equal to the force constant times the extension produced in the material. Alright, so with this I can get a formula for the k value to be k equals f over x. And for the first state, we're told that a force stretched this particular spring by 0.2 centimeters, which is now equivalent to 0.002 meters. So to know the value for k, it is very necessary that we substitute the initial force that was applied, 6 newtons, which should now be divided by the extension that is 6 Newton produced in the material, and that is 0.002 meters. Okay, so we'll say 6 divided by 0.002. That will give us 3,000 Newton per meter. This is the SI unit for the force constant, 3,000 newtons per meter. Alright, then we proceed to the second state. For the second state, we were told that an extension was produced in that same material, that is 0.02 meters. Okay, and we are told to find the work done to cause this extension. Alright, now from this formula I indicated as steric, we're told that the work done in an elastic spring is equal to 1/2 the force constant times the square of the extension produced. So simply, work done is equals 1/2 times the force constant, which is 3,000 in this case, times the extension that was mentioned in state 2, that is 0.002 all squared. So work done here will be equals, so if 2 is to go into 3,000, that will give us 1,500 times 0.002 all squared. So if we are to do that, we are going to get that 0.002 all squared times 1,500 will give us that the work done in stretching this material by 0.02 meters is 0.006 joules, because work done is measured in joules. Or if I'm to represent this in standard form, this will be 6 times 10 to the power of -3 joules. Alright, so this is the correct answer to this question stated above. If you have listened up to this particular moment, I must say I'm most grateful, and I would love you to like, share and comment if this calculation was helpful in any way. Thank you. See you in the next video.